Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers vectors. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 1. I've been given two column vectors and I've been asked to find the vector 2a plus b. Okay, so 2a plus b is going to be two lots of my vector a, which is minus 4 minus 1, plus one lot of my vector b, which is 3 minus 1. So I need to then look at 2 times minus 4 plus 3. For the top number, two lots of negative 4 is negative 8 plus 3 is negative 5. And then I need to do 2 times negative 1 times negative 1. 2 times negative 1 plus negative 1. So two lots of negative 1 is going to be negative 2 plus negative 1 is negative 3. So the vector I'm looking for is that one, which is that one there. Question 2. Work out minus 4 minus 7 minus minus 5, 3. So I've got vector subtraction here. So I need to subtract minus 4 subtract negative 5 and I need to subtract negative 7 subtract 3. So negative 4 subtract negative 5. Subtracting negative is the same as adding, so it's negative 4 plus 5, which will be 1 on the top. And then on the bottom line, minus 7 subtract 3. Minus 7 subtract 3 is minus 10. So it is that one. Question 2, work out negative 4, 8, minus 3, negative 2. These are column vectors, aren't they? Okay, and when you're subtracting column vectors, you have to kind of subtract like with like. So I'm going to do negative 4 subtract 3. So what's negative 4 subtract 3? Negative 4 subtract 3 is negative 7. So this is going to be equal to negative 7 on the top. And then subtracting the bottom one, so 8 subtract negative 2. When you take away a negative, it's the same as adding, isn't it? So 8 subtract negative 2 is the same thing as 8 plus 2. That's going to be 10. So the column vector I'm looking for is minus 7, 10. It's that one there. It's the first one. Question 2, here is vector A. Circle the column vector that represents A. Okay, well, column vectors are written in the form x, y, and that represents the distance from the starting point of the vector to the end point of the vector. How far you're going in the direction of x, which in this case is 3, and how far you're going in the direction of y. Now that's 2 units, but it's 2 units down. So that's considered to be negative 2. So this particular vector is going to be 3 where the x goes and minus 2 where the y goes. So it's that one there. Question 2. The vector negative 2, 3 translates A to B. Okay, so what does the vector negative 2, 3 look like? Vector is always given the form x over y, so that means I'm going negative 2 in the direction of x, or like 2 units to the left, and 3 units up, so 2, 3 like that. So we're going to end up with an arrow from this point down here, which could be A, and up to that one there, which is B. Now if I flip it around and I want to go in the other direction, so instead of going from A to B, I'm going from B back to A again, I'm going to go the opposite direction, aren't I? So rather than going 2 to the left, I'm going to be going 2 to the right, and rather than going 3 up, I'm going to go 3 down. So that as a vector notation is going to be 2 to the right is just 2, and 3 down is negative 3. So it's going to be 2, negative 3. It's that one there. 2 plus column vector 5, 7. Now when you are adding, subtracting column vectors, you add and subtract the same spot in both. So I'm gonna, that minus 3 there, that's the x value, isn't it? And I'm going to be adding that to the 5 there in the second column vector, and negative 3 plus 5 is 2. And then I'm going to be adding the 2 and the 7 together. 2 plus 7 is, oops, is, and 2 plus 7 is 9. Okay, so the yellow ones gave me that one, the green ones gave me that one. Okay, part B. Got a similar thing here, except I'm subtracting then. The rules for subtraction, same as the rule for adding, subtract like from like. But I've also got a scalar in front of my second column vector. I've got that 2 sitting on the outside there that I've got to deal with first. Now basically everything inside the vector gets multiplied by 2. So that gives me 3, 4, subtract 2 lots of 1 is 2, and 2 lots of negative 3 is negative 6. Okay, just as last time, and then we're now going to add the 2 top numbers together, and well, subtract, sorry, the 2 bottom numbers together. So 3 subtract 2 is going to give me 1, and 4 subtract negative 6 is going to give me 10. So the 2 yellow ones gave me that one, and the 2 green ones gave me that one there. Okay, so that's my answer. 110. Question 7. The diagram shows the vector A and B as a column vector. A equals 3, 2. Yeah, it is, because you can see if you're going from one end of A to the other end of A, you're going along 3 and you're going up 2. Can you see 3 along and 2 up? Okay, so that makes it a vector 3, 2, because in vectors, column vectors, x, the top number is in the direction of x and the bottom number is in the direction of y. Okay, so what is B as a column vector? So doing the same thing to B, how far in the direction of x is it from there to there? That's like 1, 2, 3, 4, isn't it? Okay, so that's 4 units in that direction. And then in the other direction, in the y direction, it's actually 1, but 1 downwards rather than upwards. So this as a column vector is going to be 4, because we're 4 units in the direction of x, but minus 1 because we're going 1 down rather than 1 up in the y direction. Right, and then it says work out the value of 4a as a column vector. Well, 4a is going to be equal to 4 lots of 3, 2. And when you've got a scalar like this on the outside of a column vector, you end up multiplying it by each of the numbers inside. Okay, so 4 times 3 gives you 12, and 4 times 2 gives you 8. So my final vector is going to be 12, 8. So 12 there and 8 there. Now part C says a plus c equals 3, 0. Work out the value of c as a column vector. Circle your answer. Okay, so let's write down what we know, and we'll put in some algebraic values for the ones we don't. Okay, so we know a, that is the vector 3, 2. I don't know c, so I'm just going to call it x and y, and I know what it's equal to. It's equal to 3, 0. Okay, so having a look at this, then this number here plus this number here should be equal to this number here. Okay, so because 3 plus x equals 3, it implies then that x is equal to 0. Okay, and then the other one, I've got 2 plus y, and that's equal to 0. Okay, so I've got 2 plus y equals 0. So what does that make y then? Y must be negative 2. Okay, so which one is it? It's got to be that one there. Then there's an x is 0, y is negative 2. Question 7, vectors A and 4B are drawn on the grid. And then part A says, write vector A as a column vector. Okay, so column vectors are written in the form x over y, where x is the distance from one end of the the vector to the other in the direction of x. So you can see that's 4 units in that direction. And then in the direction of y, which is, it's actually, y is how many units up it is, and this is actually 2 units down. So this is considered to be -2. So the column vector is going to be 4 units in the direction of x and -2 units in the direction of y. And then part B says find the vector b as a column vector. Okay, now we've actually got 4b here. It doesn't actually fit nicely on the grid. I'm just gonna work out what 4b is first, and then I'm going to divide it by 4, I think. So 4b, that is equal to, I'm going to do the same thing. How many units in the direction of x and how many units in the direction of y do we need to go? Well, this is 1, 2, 3, 4 units in this direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, they're being a bit cruel to us here. So that's going to be 4, 9 then. So the vector b by itself is going to be a quarter of that then. So it's going to be a quarter of 4, 9, which a quarter of 4 is just 1, isn't it? So the top number is 1. Now the bottom number is going to be 9 divided by 4, which is, I'm just going to write it as 9/4 actually. So it's 9/4. 1 and 9/4. Question 10. Two vectors A and B are shown on 1 centimeter grid below. Show that the vector A plus 2B has a length of 7 centimeters. You may use the grid below. Okay, so we've been given A and B graphically, so we've been shown them. So A plus 2B is going to be a vector A followed by 2 vector B's, isn't it? So let's draw those on. So vector A is 4 units along and 1 unit up, isn't it? So it looks like that. 4 units to the right and 1 up. So that's my vector A. And then vector B is this one up here, isn't it? So it's 2 to the left and 3 up. So 2 to the left and 3 up on my graph is going to be like that, isn't it? So that is vector B. But we're going to do 2 of those, so that's 1b, and a second b would then take me up to there, then wouldn't it? So that's vector b followed by another vector b. Okay, now if I'd have gone straight from here to here, the resultant vector then is this straight line going between the two then, isn't it? So you can call this line here, this is the resultant vector, A plus 2b then, isn't it? It's the one that takes us straight there. Okay, and you can see, well, I can just count 1, 2, 3, 4, 5, 6, 7. So it's of length 7. Question 13a. Vectors A and B are drawn on the grid. Yes, they are. And then underneath it says write down B in terms of A. Now you should be able to see from here that A is parallel to B. So they're not going in the same direction, are they? Because A is going from left to right, and where B is going the other way around by looking at the arrow, it's going from right to left. But they're in opposite directions, aren't they? So if one is positive, the other one is going to be negative then. So write B in terms of A, but you can also see that from one end of the line to the other, it's like 3 along and 2 up. So if I did that here, look, 3 along, 2 up, 3 along, 2 up. You can see that the vector A fits into the magnitude of vector B twice. So B is twice as long as in, and in the opposite direction to A, it's going to be -2 lots of A then, isn't it? So B is -2 lots of vector A. Okay? Now draw an A with a little hat like that because it's a vector. And I can't draw in bold. I don't know if you've seen that these are written in bold. Now I can't write in bold, so I put a little line on the top to show it's a vector. Question 13. B Vectors C and D are drawn on the grid. Yes, they are. On the grid above, draw the vector representing C minus D. Okay, C minus D means going along vector C and going against vector D. Okay, so I'm going to start. So C is going from right to left and D is going from left to right, but we want to do a minus D, so it's the other way around. So I need to really, I'm going to start on the right hand side of my paper, otherwise I'm not going to fit it all in. So let's start at this point here. Vector C goes 1 to the left and 2 up. So it's going to take me from there to there. Okay, now D is normally 1, 2, 3, 4, 5, 6, 7 units to the right. But if I want to do minus D, I want to go the opposite way. So I'm going to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. Okay, so that's vector C and that's vector D. So from there to there then is vector C minus D. Okay, so actually we want to draw a vector representing C minus D. Now that's the resultant vector of those two. Okay, so if I was going directly from C, my starting point, to D, my end point, my resultant vector then is this. Good, let me draw a pen. Okay, there we go. So from here to here, going straight, now that is the vector C minus D. Question 9. Vector A is 3 minus 1 and vector B is 1, 3. Find the values of k and n such that k lots of a plus b equals 10 over n. Okay, so k times a plus b is equal to 10n. Let's sub in our vectors a and b. So that's k lots of 3 minus 1 plus 1, 3. And we know that that is equal to 10 over n. So add in, when you add two vectors together, you add like with like, don't you? So we're going to add those, the 3 and the 1 together, and we're going to add the minus 1 and the 3 together. So that's going to give me k lots of 4, 2, and that is equal to 10n. Okay? Now when you multiply a vector by a scalar, you're going to multiply both the 4 and the 2 by k. Okay? So that tells me that 4k, 2k is equal to 10 and n. Okay? So then comparing like with like then, so I've got this 4k here and that's equal to 10, and I've got this 5k here and that's going to have to be equal to n then, isn't it? Sorry, 2k here is going to be equal to n. So I can equate those now. I can say that 4k must be equal to 10, which implies that k is equal to 10 divided by 4, which is 2.5. And I can say that 2k is equal to n. Now I know that k is 2.5 now, so 2k is 5, so n must be equal to 5. So k is 2.5 and n is 5. Part B says Gavin starts to draw a diagram to show that a plus 2b is 5, 5. Complete Gavin's diagram. Okay, so you recall that a then was the vector 3 minus 1 and b was the vector 1, 3, wasn't it? Okay, so from there I can see that this vector down here, this bottom side of the triangle here, is, let me just put an arrow on it to show you, this one here is the vector a, isn't it? Okay, so I can label that one a, because you can see for every 3 units you're going along, you're going 1 down. Okay, now this side here, from here to here, that is vector b. So I'm going to draw an arrow on there as well. So that is vector b. That takes me 1 along and 3 up. Okay, so then I've got another b here. So this long line here is actually 2 lots of b, isn't it? So I've got vector a and then vector b, and that takes me from there up to there. And we're told that's equal to 5, 5, is it? Well, if you count from where we started to where we ended up, you can see that that is 5, 5, isn't it? So the resultant vector is 5, 5. Okay. So yeah, I think that's fine. So I'm just going to label the vertices on the vectors on there appropriately, and that should complete the diagram. I think that's. Question 11. I've been given A, B, and C as column vectors, and I need to work out what A plus B plus C is. Okay, so if I want to add these three vectors together, I'm going to be adding 6 minus 10. I'm going to be adding on -1, 2, and C, which is -4 over 7. So when I add column vectors like this, I'm going to be adding like the x components together. Those three are going to get added together, and I'm going to add the y components together, the -10, the 2, and the 7. Okay, so what does that give me then? 6 plus -1 is 5, plus -4 is 1, and -10 plus 2 is -8, plus 7 is -1. So that's going to give me 1, -1, 1, -1. Part B says, show that A plus 2C is parallel to B. Okay, now to show that two vectors are parallel, you need to show that one is a multiple of the other. Okay, so either equal to each other or as one is a multiple of the other one. Okay, so let's add A and 2C together first and find out what we've got. So what is A plus 2 lots of C? That's going to be my vector A, which is 6 minus 10. 6 minus 10. And I'm going to add on 2 lots of vector C, which is -4, 7. Okay. So this time I've got a scalar times a column vector. So both numbers in my vector get multiplied by 2. I'm going to do that one first, a bit like BidMaths. I'm going to do multiplication before I do addition. So I'm going to leave that one as it is to start with. And then 2 lots of -4, 7 is going to be 2 lots of -4, which is -8, and 2 lots of 7, which is 14. So I've got those, which I now need to add together. And just like last time, the 6 plus the -8 and the -10 plus the 14 is going to give me my resultant vector, which is -2. -10 plus 14 is 4, -2, 4. Okay, now I need to show then that -2, 4 is a multiple of vector B. Now vector B was the vector -1, 2. Okay, now you'll notice that -2 and 4 are we've both got 2 as a factor. So I can factorize out 2 and write it as a scalar of that vector instead. So I can factorize out 2, which leaves me -1, 2 inside the bracket. And that, you'll notice, is the same as vector B. So I've got 2 lots of vector B. Okay, so I have shown that A plus 2C is equal to 2 lots of vector B, and therefore they are parallel. Okay. Question 20. Vector M is 2k and vector n is 311. Vector 2m plus n is parallel to 1 minus 1. Find the value of k. Okay. So let's find out what 2m plus n is first off, and then we'll worry about the parallel bit in a minute. So the vector 2m plus n then is going to be 2 lots of my vector 2k plus my vector 311. Okay. So first off, I'm going to multiply out. I'm going to deal with this scalar here on the outside. Now I can do that just by multiplying everything inside the column vector by 2. So that's going to give me 4 2k. So 4 2k plus 311. and then I'm going to add like with like. So I'm going to add the 4 with the 3, and I'm going to add the 2k with the 11. Okay, so that's going to give me 7 2k plus 11 as my vector. Okay, now we are told that that is parallel to 1 minus 1. Okay, so that means that this must be, if two vectors are parallel, it means that one must be a multiple of the other. So it's got to be some multiple of that vector 1 minus 1, like that. Okay, so in other words, 7 has got, and again, if I multiply that out, so 7 2k plus 11 is equal to m minus m. Then again, if I compare this one with this one, then I can see that m equals 7. And then if I compare this one with this one, then I can see that 2k plus 11 must be the same thing as minus m, which we've just found out is 7. So I can say that 2k plus 11 equals minus 7. Okay, then subtracting 11 from both sides, I'm going to get 2k equals minus 7 minus 11 as minus 18, and then dividing both sides by 2, I'm going to get k is negative 9. K is negative 9. Now, if you're wondering where this m came from here, it's not mentioned anywhere in the question. I just made it up. I shouldn't really have used m because I've got another vector called m, so naughty, naughty me. I just meant that to be some sort of value like x that we don't know what it is yet, but we're gonna find out what it is later. Okay, so I introduced that m. It's not the same thing as this vector up here, because if you remember, I wrote my vectors with the line over the top so you could see that they were vectors. This is just a scalar. I just used it to show that that these two vectors were parallel. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.